Hi, welcome along. In this clip we're going to take a look at how to measure some noise cancellation earphones. We have here a couple of noise cancelling earbuds. These are configured as feedback earbuds. Although different to feed forward, there's a lot of similarity. The PCB here is using the AMS active noise cancellation IC, and this has a I2C interface to allow us to communicate to the chip. The socket on the test system provides us with the power supply and the I2C interface. We can see that we're connected now by the LED flashing. That just confirms to us that we're connected. Next of all, we're going to go ahead and test it. So we have an air simulator here. Let's plug in our earphones right to right and left to left and line in. That looks set. Now let's move over to the software and take a look at how the measurement proceeds. So let's get the measurement underway. What we'll see here is just the raw data as it's coming in. 2 steps to the measurement, passive and active mode. Then we take a difference curve to resolve the noise cancelling response. If you're not familiar with that curve, we'll talk about that a little bit more later. The noise cancelling response is progressively adjusted to hit our target range. And once we hit it, there we see everything goes green and we're passed. Let's run this a few times. We'll start the auto start mechanism and let it cycle a couple of times just to see how this runs. What you'll notice is at the bottom of the screen of the noise cancelling curve, there's a message there telling us that we've hacked the code to set up a random starting gain. This is a crude attempt to simulate the variation of microphone gains that we'd see in a production environment. So we'll let that cycle through a couple of times. So as you can see on the top of the screen there we have PN. It's an acronym for passive noise spectrum, and AN, the active noise spectrum. The difference between those two noise spectrums determines the noise cancellation response. As we can see, the noise cancelling, the active noise is cycled with increased gain until we hit our target noise cancelling response, and in this case it's about 18 dB. So one more run with this setup. And again, the starting gain, which is the first noise cancellation response we see in each test cycle, has some random mic value. In practice, of course, we would set this very close to the final mic value. Now let's go ahead and try a more comprehensive test setup. We'll call this one complete, which will include full frequency response measurements. So in this case, the first measurement that we see is PFRL, passive frequency response left. There's our upper and lower bound mask, and the passive frequency response right. Then we'll go ahead and collect the noise spectrum as we just saw, the active noise spectrum. In this case we're actually going to plot those two out so we can see the noise curves, and there's our familiar noise cancellation curve. Once that hits the target range, we'll proceed to the active frequency response, and this will be the last measurement in the sequence. Again, we have upper and lower bounds, and we're pretty happy with that. Let's take a look at this. Here's the passive frequency response, which is generated as a full transfer function including magnitude and phase. We define some criteria including the sensitivity and upper and lower mask. The noise spectrum here, we can see that there's 2 pairs of curves. The slightly higher pair is passive and the lower is the active. This curve is in fact the difference between those 2 noise spectrums. There we go, code hacked. And the active frequency response, just as we saw with the passive frequency response, we generally apply an upper and lower mask.